Hi everyone, welcome to Integral Calculus. Today we explore lesson 5.3, the Fundamental Theorem of Calculus, part 2. First, let's take a list of some antiderivatives. We have function x to the n. The antiderivative of x to the n is xn plus 1 over n plus 1. We don't have to do the plus c because we can use a particular antiderivative in which c equal to 0. And this is only true if n is different from -1. Well, what happens if we have x to the -1? The antiderivative is ln absolute value x. Antiderivative of e to the x is e to the x. Antiderivative of psi x is negative cosine x. Antiderivative of cosine x is psi x. There are many more. You just have to either look into the textbook or online for them. These are the useful antiderivative that we're gonna use in the example that we do next. Let's move on to number 1. Evaluate definite integral. Let's begin with integral from 0 to 2. X minus 1 square dx. We don't have antiderivative of x minus 1 to the power 2. So we got to FOIL it out. Integral 0 to 2, FOIL it out, and we have x squared minus 2x plus 1 dx. Now take the antiderivative of each term. Antiderivative of x squared is x 3 over 3. Antiderivative of x is x squared over 2, and antiderivative of 1 is x. Evaluate from 0 to 2. So in order to evaluate this, we sub in 2 first, and then we sub in 0. Sub x equal 2, we have 2 to the power 3, a over 3 minus 4 plus 2. When we sub in 0, we get 0. This from the Fundamental Theorem of Calculus, part 2, it is exactly f of 2 minus f of 0. Okay. A over 3 minus 2 is the 2 over 3. Pretty cool. Let's take a look at another example. Integral from 1 to 2. 4 plus x squared over x to the power 3 dx. Same thing here. We cannot find the antiderivative of this rational function directly. So we have to split the fraction and simplify. Split and simplify get us 4x to the -3 plus 1 over x dx. The antiderivative of x to the -3 is 4x minus 3 plus 1 is minus 2 over minus 2. And this is ln absolute value x. Evaluate from 1 to 2. Plug in 2, so we have a -2 times 2 to the -2, -2, 2 to the -2, plus ln 2. When we plug in the number 1, we have a -2 times 1 to the -2 plus ln 1. Okay, so that's -2/4 plus ln 2 minus turn to a plus, so that's the +2 ln 1 is 0. Yay! And yeah, -2/4 plus 2 is 3/2 plus ln 2. Pretty cool, huh? One more. Here comes C. Let's do a integral of 0 to pi/2 7 sine x minus cosine x dx. Integral of sine negative cosine, so 7 minus cosine x. Integral of cosine is sine x. Evaluate this one from 0 to pi/2. Cosine of pi/2 is 0, so we have a 7 times 0. Sine of pi/2 is 1 minus cosine of 0 is 1, so 7 times -1 minus sine of 0 is 0. Oh, what do we have here? We have a -1 plus 7. So this -1 minus this plus 7. 6. Very cool. There are some functions that we can quickly evaluate the integral, given that the function are symmetric function, symmetric over the y-axis or about the y-axis, symmetric about y-axis. F of negative x equal fx. Now we call this function even function. Fx is called even function. What is so cool about this is that when we take the integral from -a to a of fx dx, well, this is the same as 2 times the integral from 0 to a fx dx, because it is symmetric about the y-axis. Let's take a look at an example. Example, integral -2 to 2 x squared dx. We're going to test the x squared here. We know that fx is x squared, f of -x -x squared, which is x squared, and that is the same as fx. So it is an even function, and therefore the integral is the same as 2 times the integral from 0 to 2 x squared dx, which is 2 times antiderivative x squared x to the power 3/3, 0 to 2, and we have 2 times a/3 minus 0. That gets us 10/3. Quick. Okay, another one is symmetric about the origin. Symmetric about the origin. In this case, f of negative x is negative f of x, and fx is call it odd function. The integral from negative a to a fx dx is 0 because one side of the area is negative, the other side is positive. They cancel each other out. Let's take a look at an example. Integral negative 2 to 2 x to the 3 dx. Fx is x to the 3. F of negative x is negative x to the 3, which is negative x to the power 3. And that is exactly negative of the function. Well, from here, we know that the integral is just 0. I'm going to actually evaluate this thing and show that it is 0. Okay. Antiderivative of x to the 3 is x to the 4 over 4. Negative 2 to 2. Right? So what do we have here? We have a 2 to the 4. That is 16 over 4 minus negative 2 to the 4. You see, 16 over 4. 0. Best to use the fact that the function is odd and immediately get 0. There are some special functions that I want us to take a look at. The first special function is integral 0 to 1 square root 1 minus x squared dx. Well, we cannot get rid of the square root. So how do we find the antiderivative of this function? It is not possible. There must be another way to do it. And that is, remember, definite integral is area under the curve, right? So we just have to figure out what exactly is this curve here. Gonna let y equal to root of 1 minus x squared. And y squared is 1 minus x squared. And therefore, x squared plus y squared equal 1. So what we have here is a circle center at origin and radius is 1. So it's this circle here. However, since we have the square root of 1 minus x squared, we only have half of the circle because square root is always non-negative. This is y equal root of 1 minus x squared. And when we evaluate the integral from 0 to 1, that is exactly what the evaluation does. It's the area. Area is integral from 0 to 1, root of 1 minus x squared dx. So what we see here is that this is just a 1/4 of the area of a circle. 1/4 pi r squared. Well, the circle here has a radius of 1, just 1/4 pi times 1 square, and that is pi over 4. Pretty amazing, huh? Here comes a second amazing function. B. Integral from 0 to 3, absolute value, 3x minus 6 dx. Absolute value function is very important in physics because it will distinguish between displacement and distance travel. So how do we do this integration here? Well, we can split out the absolute value function. Remember that the absolute value x equal to x if x greater than or equal to 0, negative x if x less than 0. I'm going to use the definition here to split the absolute value of 3x minus 6 into a piecewise function. So it would be 3x minus 6 if 3x minus 6 greater than or equal to 0, and going to be negative of 3x minus 6 if 3x minus 6 less than 0. Simplify this and we have 3x minus 6 if x greater than or equal to 6 minus 3x if x less than 2. This integral is split into two pieces. One is from 0 to 2, 6 minus 3x dx. The other one is for x greater than or equal to 2. Well, so it will be from 2 to 3, 3x minus 6 dx. Yay! Well, we know the antiderivative of 6. 6x antiderivative of x is x squared over 2. And on the other side, 3 times x squared over 2 minus 6x. Evaluate from 2 to 3. Plug in the 2, then we have a 12 minus 3 times 2. Yeah. When we plug in 0, we get 0. On the other side, plug in 3. So 3 squared 9, 27 over 2. Minus 6 times 3 is 18. Minus, okay, plug in the number 2. And we have a 3 times 2 minus 6 times 2. Okay. 12 minus 6 is 6. And this one would be 27 over 2 minus 18 is the 27 minus 36. That's negative 9 over 2. Okay. 6 minus 12, so negative 6 plus 6. Oh, what do we have here? We have 12 minus 9 over 2, which is 12, 24 over 2. 24 minus 9 is 15 over 2. Thank you for watching. I hope you like the content of the video. Please like and subscribe to help the channel grow. I'll see you in the next video.